All right, today we're diving deep into something that powers pretty much everything we do online. It's one of the most important and maybe one of the most misunderstood technologies out there. We're talking about cloud computing.
Think about this for a second. What if all the apps, all the photos, all the data you use every single day weren't actually on your phone or your laptop? What if they were just floating somewhere out there in a vast digital sky? That's the whole idea behind the cloud, right? It's the invisible backbone of our entire digital world. But what is it, really?
Well, here's the first surprise. Despite the name, the cloud has absolutely nothing to do with the weather. We all have this image in our head of this abstract, kind of magical thing. But the reality? Oh, it's very, very real. We're talking about thousands of miles of fiber optic cables buried under the ocean and these massive hyper-secure buildings packed to the gills with powerful computers.
So, if we really want to get what the cloud is all about, we have to kind of forget the fluffy metaphor and start thinking about the actual machinery. Because at the end of the day, the cloud isn't some mystical thing up in the sky. It's a global network of computers.
You know, there's a popular saying that cuts right through all the marketing fluff. It goes, there is no cloud, there are just other people's servers. And honestly, that's the simplest, most direct way to think about it. When you save a file to the cloud, you're really just saving it to a hard drive on a computer that's owned by a company like Amazon or Google or Microsoft.
Here's a great analogy. Think about electricity. You plug your lamp into the wall and the light comes on. You don't need to own your own power plant, right? You just tap into the grid. Well, cloud computing is pretty much the same thing for, well, computing. It lets you tap into massive computing resources over the internet whenever you need them. You just pay for what you use, whether that's storage space, processing power, or a piece of software. Okay, so if the cloud is really just these giant warehouses full of computers, what do they actually look like inside? What's going on in there? These places, these data centers, are seriously impressive. They're often in these nondescript buildings you drive right past without a second glance, but inside, they're like fortresses. We're talking state-of-the-art security, super advanced systems for power, cooling, and fire suppression, the whole 9 yards. And they're not just randomly placed. Cloud providers build them in strategic regions all over the globe, and each region has multiple, separate availability zones to make sure everything stays up and running. And that architecture, that setup, is exactly how the cloud stays so reliable. See, your data isn't just sitting on one lonely server somewhere. No way. It's copied and spread across multiple locations. So if one data center has a hiccup, maybe a power outage or something, your traffic just gets automatically rerouted to another one. This is called redundancy and load balancing, and it's the reason why services like Netflix or Gmail basically never go down. But think about it. How do these companies manage all that hardware efficiently? It would be crazy expensive and wasteful to give every single customer their own giant physical server. So how do they do it? Well, there's a secret ingredient, a bit of technological magic called virtualization.
Virtualization is the real game changer here. It's this amazing technology that lets you create a software-based or virtual version of a computer. This means you can take one single super powerful physical server and digitally slice it up so it acts like a bunch of smaller, totally independent servers all running at the same time. And the software that pulls off this trick is called a hypervisor. I love this analogy. Think of the physical server as a big apartment building. The hypervisor is like the building's landlord. It divides the whole building into individual, secure apartments. Those are your virtual machines, and it makes sure every tenant gets the exact space and utilities they're paying for without ever bumping into their neighbors.
So let's just walk through it real quick. It's pretty straightforward. First, you start with one monster of a physical machine. Then you install the hypervisor software right onto the hardware. From there, the hypervisor starts carving out resources, a little bit of CPU here, some memory there, a chunk of storage, to create these totally isolated virtual machines. And here's the coolest part. Each of those virtual machines can run its own operating system and its own apps, and it has no idea it's even sharing hardware with anyone else.
Okay, so we've covered where our data lives and how it's all organized. But how does it get from a data center halfway across the world to your screen in like the blink of an eye?
You know, every single time you click a link or tap play on a video, you set off this incredible high-speed journey. Your request zips from your device, shoots across the global internet backbone, and finds the exact data center it needs, which could be thousands of miles away. A server there grabs your request, processes it, finds the data, and sends it all the way back to you. And this whole round trip happens in milliseconds. It's just wild. And really, The unsung hero of this entire global nervous system is the fiber optic cable. The backbone of the internet is this gigantic network of these cables, and a lot of them are just lying on the ocean floor. They transmit data as literal pulses of light. They are unbelievably fast, way more secure than old copper wires, and a whole lot more energy efficient too.
All right, so we get the physical stuff, we get the virtual stuff, but how do you or I or big companies actually use all this? Well, it's not a one-size-fits-all deal. It's usually broken down into three main ways, or three main service models.
But hold on. Before we dive into those models, there's a really key idea we need to get our heads around. It's called the shared responsibility model. Basically, cloud security is a partnership. The cloud provider, think Amazon or Google, is responsible for the security of the cloud. That means the physical buildings, the hardware, the network. But you, the customer, are responsible for security in the cloud. That's your data, your apps, and who you give access to. This is a super important distinction for understanding how these services actually work.
Okay, that brings us to the three main flavors of cloud services. First up, you've got IaaS, or Infrastructure as a Service. The best analogy is renting a piece of land. The provider gives you the basic building blocks, virtual servers, storage, and you can build whatever you want on top of it. Then there's PaaS, Platform as a Service. This is more like renting a fully equipped workshop. The provider handles all the underlying stuff, so developers can just show up and start building their apps. And finally, the one we all know and love, SaaS, or Software as a Service. This is like moving into a fully furnished apartment. Everything is ready to go. You just use the software, like Gmail or Netflix, and the provider takes care of everything else.
So that last one, SaaS, that's the one most of us are using all day, every day, probably without even thinking about it. So where do you see it in your daily life?
Well, think about it. Every time you binge a show on Netflix, your device is pulling all that video data from their cloud servers. When you check your email with Gmail, the app itself and every single email you've ever sent or received lives in Google's cloud. Storing your photos in iCloud, sharing a file on Dropbox, collaborating on a Google Doc? Yep, all classic examples of software as a service, and all of it is powered by that massive invisible infrastructure we just talked about.
So the cloud has already completely changed our world, but it's not even close to being done. It is the launchpad for the next giant leap in technology.
I mean, look at what's happening. The insane amount of processing power that's needed for things like artificial intelligence and machine learning. That's only possible because of the cloud's ability to scale up. The Internet of Things, with billions of smart devices all sending back data, it relies completely on the cloud to store and make sense of it all. And now we're seeing the rise of edge computing, which actually pushes the cloud's power closer to us, reducing lag time for things like self-driving cars. But of course, this incredible growth comes with some equally incredible challenges. I mean, protecting all that sensitive data from constant cyber threats is a massive, ongoing battle. And then there's the environmental cost. These data centers use a mind-boggling amount of power and water, which makes sustainability one of the biggest, most critical problems the industry has to solve.
So the next time you save a photo or stream a movie, just take a second to think about what's really happening. It isn't magic. It's not some fluffy white cloud in the sky. It's a very real, incredibly complex, and powerful global machine. Because at the end of the day, the cloud isn't just a place where we store our stuff, it's where the entire future of computing is being built.